Welcome back, everyone, to Generative Adversarial Networks. In part one, we're just going to briefly go over uploading our data. Now, to save on training time, what we're actually going to be doing is we're working with the MNIST dataset, a dataset that we're very familiar with. That way we can focus on how the generator and discriminator actually work instead of focusing on learning about a new dataset. But the other thing we're going to be doing is to save on training time and to really see how the generator and discriminator work, we're going to be filtering out the MNIST dataset to only select a single digit. So we'll select all the zeros, for instance, and then we can clearly see the generator be able to generate images that look like a zero. Okay, let's head over to the notebook and get started. All right, here I am at the notebook. I've already imported NumPy as NP, pandas as PD, and matplotlib.pyplot as PLT. And let's load up our MNIST dataset. We can do this by saying from tensorflow.keras.datasets import MNIST. So this is a dataset that we're already actually very familiar with. So what we'll go ahead and do is we'll simply use the tuple unpacking to grab it. We'll grab the X-train and Y-train subset of those tuples, and then the X-test and Y-test. And we run this with mnist.load data. Okay, so we load up our data. Let's go ahead and use PLT imshow to display one of these 2D arrays. Let's go ahead and grab that first image, X-train 0, and we can see it's a 5. Okay, and recall that the actual Y data is essentially just the actual number itself. So we can see on Y-train that first one was the 5, corresponds to this image. So what I want to do is I want to filter out the data for two reasons. One is to get a little bit of a smaller data set for faster training, and two, so we can clearly understand the generator is working or not. So what I want you to do is choose one of these numbers to actually feed and generate data from. So what I mean by that is, for instance, I'm going to select only zeros, and you can go ahead and follow along with me by saying X-train where Y-train is equal to zeros. So notice here I have Y-train, and if I were to say where's Y-train equal to zeros, then I get this tuple of, or excuse me, this NumPy array of booleans, false, true, false, false, etc. And so I'm going to use these actual boolean indices to then only grab those corresponding X-train images, essentially allowing me to only grab the 0 images. And now if I take a look at only zeros dot shape, notice now I have around 6,000 images. The actual size of my full data set, recall, is about 10 times as much, 60,000 images. So we're dealing with a much smaller data set, and what's nice is now all of these numbers essentially look more or less the same. So any of these, for example, whoops, not only train, only zeros. So any of these guys, just go ahead and choose any random number between 0 and 5,923, and if you actually show it, PLT imshow, they're all essentially these kind of zero looking things. So they should be kind of looking like donuts or these rings, which is kind of nice because that way we can be able to tell if our generator is actually learning from our very particular data set. So I would encourage you to choose a number, and if you want you can choose zeros like us because it's a very distinct shape. We can see here that there's essentially no values on the outside, then we suddenly have our values as a string, and then no values on the inside. It's a very particular shape, and it's going to be hard for the generator to mistakenly make this from just random noise. So this is a very distinct shape, so we'll be able to tell whether or not our generator is learning from it. Okay, so that's it for the data. What we've done here is we just loaded up our data set, and then only using the X-train data set, what we did is we filtered down and chose one particular number. If you want to follow along exactly with us, go ahead and just choose zeros. But what's fun about this is then you can change this Y-train to equal any number from the MNIST digit data set. Okay, coming up next, we're going to focus on is actually creating the generator and the discriminator. I'll see you there.